As I promised to bring different kinds of functions, we have this type of function which is rational function. If you want to find the domain and range, you have the restriction here. This line, the red line. This rational function 11x plus 2 over 2x cubed minus 1. 2x cubed minus 1 never be 0. Never. So to find the domain, we need to not to equal the denominator. Denominator cannot be 0. Then if you add 1 to both sides, then 2x cubed will be 1. Then you divide both sides by 2, then x cubed equals a half. Then radical cube both sides, x equals radical cubed. So let's do it step by step. Radical cube of x cubed. Then x equals radical cubed of a half. Doesn't equal. Remember that. Doesn't equal. Shouldn't equal cube root of x of 1 over 2. So domain, all real numbers could exist except this number, which is radical a half, third radical of half, or cube root of a half. So you could say that domain is all real numbers except cube root of a half. And for the range, if you track the function, the minimum point will be down to negative infinity, and the maximum point up to positive infinity. No gaps here, no asymptotes. This is a vertical asymptote we'll talk about later, which is x equals cube root of a half. So we could say that range is all real numbers for this function. We have another type of function, which is y equals 3/4 of x squared minus 1 exponent 2/3. If you want to find the domain, so look, if we track the domain over here, so you will see that we're coming from negative infinity, then we come closer to negative 1. That's fine. Jump down to 0, intersection here, okay, and then up again a little bit at specific point, which is y-intercept, could equal it to 0, equal x to 0, then find y-intercept, which is 0 minus 1 is negative 1, then it will be 1, so it will be 3/4, the y-intercept 3/4. Then keep tracking. Look at the green point. This green point is moving along the domain, and this yellow point is moving along the curve that we have, and this is vertical projection of this point. You will see that the green point is moving from negative infinity to positive infinity, no interruption. So we could say that domain is all real numbers. Domain is all real numbers. Okay, you could have different formula, that's fine. Negative infinity to positive infinity, all are working, or an equality form, which is x between negative infinity to positive infinity. For the range, if you track the point and you look at y, you're going to see that the minimum points you have will have a horizontal projection at 0. This is the minimum point we have. Never jump under x-axis, it's stopped by here. When you look at y-axis, you will see 0. 0 is the minimum point you could have it on y. Then maximum is going to infinity. You see this arm is going up to infinity, and this arm is going up to infinity. When you go up with infinity, this point will be to infinity with it, to infinity million. So you could conclude that range is from 0 to infinity. We include 0, of course, till infinity. Another kind of function, but this time is not graph. We have the equation of the function, and they ask you find the natural domain and graph of the functions. So function 1, f of x equals 5 minus 2x. Once you see linear function, close your eyes and say, okay, domain is all real numbers. Range is all real numbers. That's it. It's from negative infinity to positive infinity. Okay, that's for any linear function, any linear function. For radical function, before you decide to substitute for, if you have square root of x, the situation will be different, because you start to substitute for 0, and then 1, and then 2, it will be working. You have output. Square root of 0 is 0, square root of 1 is 1, square root of 2 is square root of 2. Always is working from 0 and above. From 0 to infinity will be working. So domain will be from 0 to positive infinity. But you cannot have less than 0. If you have negative number, it's not going to work. Because you remember, radical negative is not real, it's imaginary. But for this case, you have absolute value. Because I have seen this in a test, and some students give me this. They say, okay, for that, the domain is from 0 to infinity. This will be right if no absolute value here. I'll tell you why now. So how to respond to this question? Find domain and range. Radical absolute value of x. Okay. Square root of absolute value of x. If you substitute for 0, it will give us 0, no doubt. Absolute value of 0 is 0, and square root of 0 is 0. If you substitute for 1, then 1, absolute value of 1 is 1, square root of 1 is 1. So here is domain, range. If you substitute for 2, 3, 4, it will be working. Square root of 4, absolute value of 4 is 4, square root of 4 is 2. And continue. Continue. Now we bring numbers less than 0. If you bring negative 1, absolute value of negative 1 is 1. Then the square root of 1 is 1. So if you bring negative 1, you will have value. You have matched value output, 1. And you do the same, negative 2 will be 2, then square root of 2 is square root of 2. Then negative 4, it will be absolute value of negative 4 is 4, square root of 4 is 2, and continue. It has values. So we could conclude, I heard you now, that you're saying that domain is all real numbers, all are, all, it's from negative infinity to positive infinity, right? That's our domain, takes all values. But when you come to range, some of you said all real numbers. No, look at that. Look at that. The smallest number we have is 0. Then it's going higher and higher to the left and right equally. Looks like I feel it and I see it. It's going higher and higher. If you go to the right or you go to the left, 1, 2, 3. So the minimum is 0 and maximum could be infinity. So we could say that range will be from 0 to infinity. We close the 0 because we have it already. Infinity, we don't know where is infinity. So we open it. This is the way that you respond to this kind of question.